Okay, let's start on the right-hand side here with the vertex form of a parabola. We know it's a parabola because it'll have that squared there. So when we're talking about the shift, this has been shifted h units to the right and k units up. So your vertex is the opposite of the signs you see. Here it was subtracting h, negative h, here it'll be a positive h. Same thing with when it's a negative k, your vertex is really a positive k. So when we find that axis of symmetry, x equals makes it a vertical line. It is going through the x coordinate of the vertex. The minimum and the maximum depends on that a value. So if a is positive, this parabola opens up, it'll have a minimum. That vertex is the smallest value. If a is negative, that's when you'll get a maximum. Since your parabola is opening down, this vertex here is now the top point. A value is also special because if we take the absolute value of a and it's less than 1, this is actually wider than the graph y equals x squared is what we compare it to. When we take the absolute value of a and it equals 1, that's when it's the exact same width as y equals x squared. And if we take that absolute value of a and it's greater than 1, that's when it's actually narrower. So what I mean by that is wider. It'll take a long time to get some high y values. If it's the same, it'll look something like that. If it's narrower, it's increasing very quickly. Underneath this table, where you have room on your sheet, I want you to add a couple key letters that'll be in our formulas that we'll write down in a second. So you're going to see a capital P. This is standing for the perimeter of the base. That cursive L is a special part of our 3D figures. It's the slant height, the height of one of those slanted sides. So on a pyramid, the height of one of those triangles, or if it's a cone, the length of that straight side. We have a capital H. This is the height of a 3D figure. Also the distance between the bases. When we talk about a lowercase h, that's the height of just a two-dimensional figure. Same thing with the capital B. This is the area of the base. And if it's an S, this is really one of those side lengths of a square. So we can use those letters in the following formulas. So if I have a prism, I'm going to go ahead and sketch out a picture of that. Okay, those triangles are my two bases. So here I have a triangular prism. In order to find the lateral area, I have to take the perimeter of the base times the height of the whole prism. Surface area then is when I take the lateral area. Since there's two triangles, I have to add in two base areas. And when I look for the volume, I take the area of the base times the height. If I think about a rectangular prism, kind of sketch out this box. Again, my lateral area is taking the perimeter of the base times the height. Surface area is still lateral area plus two bases. And when I think about my volume, though, I can say length times width times height. Just multiply those three dimensions together. For a cube, we're using for the lateral area 4 times s squared. S again is just the side length of each side of the cube. Surface area is including all 6 faces, so 6s squared. And our volume then becomes s cubed when you take the length times the width times the height. Cylinder has 2 circle bases. So since we're talking about circles, our formula is going to take 2 pi RH. With the surface area, take your lateral area and add 2 pi r squared since it has 2 circle bases. And when you're calculating the volume, take the area of the base, pi r squared, times the height of the whole cylinder. For a pyramid, here's the square pyramid here. For the lateral area, I'm going to take 1/2 times the perimeter of the base times that cursive L for slant height. Surface area then takes that lateral area and adds in the area of just one base. And for the volume, we take 1/3 the base area times the height of the whole pyramid. Here's my cone, circle base. In order to find the lateral area, pi times the radius times the slant height. Surface area takes that lateral area and it adds pi r squared. And for the volume, we take 1/3 times pi times the radius squared times the height of the cone. When we get to the sphere, there is no lateral area. Since there's no bases, we can just find the surface area, 4 pi r squared. And for the volume, then we're taking 4/3 pi r cubed.